Hi, I'm Megha Daga. I'm the Senior Product Manager here at Cadence Tensilica, and I'm here today to talk about our Neural Network Compiler. Tensilica Neural Network Compiler is supposed to work with all our AI-catered DSPs. What it's providing is enablement of AI on those DSPs. We all understand having a DSP, a hardware feature for AI is one thing, but it's incomplete without a complete compiler suite against it, which is what Tensilica Neural Network DSP gives. So I will start to draw various blocks inside it and try to explain it where it is standing. So Tensilica Neural Network DSP, what it needs is a trained floating point network. These trained floating point networks can be coming from Caffe or TensorFlow like frameworks. And once these 32-bit trained floating point frameworks come, the first stage it goes inside our neural network compiler is the analyzer and the quantizer. The analyzer does a work of going through the networks, the layers within the networks, and understanding how those layers work together. And the quantizer is where we do our own custom quantization, where we are converting those 32-bit trained floating point weights into 8-bit. And we are doing a quantization of both weights and the data. So we are making sure we are sustaining an 8-bit throughput overall in the network. And still we are maintaining negligible accuracy loss in that. Once the quantizer is done, it goes through optimizer. Optimizer has jobs several folds. Some of them starts with DMA management. All our DSPs, our processors are enabled with integrated DMA. So we need the DMA manager to take care of intelligently getting that data through the AXI interfaces from the system memory into the local memory and understand how much memory are actually present, how much data can I bring, how much can I do in parallel with the compute capability of that core. All that intelligence goes in the DMA management. Then comes the tile management. These are all DSPs and processors. So they work on a tile basis, at a tile by tile. So it will take care of those tiles and how to split the image into tiles and get the tile at a time into this local memory. Then that, it has a set of NN libraries. These NN libraries are optimized libraries for a specific core. They are design specific for any of the Tensilica cores, and this optimizer will pick the correct library from this suite of library. For example, if I'm looking at a function, a 5x5 convolution, I might have in my library 7 different flavors of that. Now the job of this optimizer is to pick that right one based on the spatial and the kernel dimensions it is seeing. So it will pick the right NN lib from there. And once it is done with all that, it will also do some steps like kernel fusion, it will do some reduction and some of the optimization features in the neural network and then spit out a source code. So the end of this is a source code, which is again something viewable to the customers. Customers can take this source code onto our Extensa programmable generator where they can do the simulation, they can test it, they can profile it, they can debug it, and if they need, they can tweak it. This source code generated is very specific to, like I said about the NN lib, it's specific to the DSP or the processor underneath it. These can be anywhere from Vision P6, Vision C5, Vision Q6, or our latest announcement of DNA 100. So this tool is something which is sitting on top of all these processors and catering to all of them in the most optimum way. Some of the other features which not listed over here and which are very helpful is custom layers. Custom layers are something which we have seen are coming more and more in demand. Neural networks, there are standard neural networks, but customer always want to put their own custom flavor into it. And with that, they can introduce some layers which are not defined by standard, but they want to have it, and for that they define custom layer. So we have an interface over here where they can easily plug in their custom layer into our network, and we will generate the source code with a placeholder for that custom layer. We also have been looking and adding on to various kind of network definitions, be it classification, segmentation, object detection, all those recurrent network definitions, those are all getting added to these. So it caters to a huge range of network definitions. It's also looking into multi-core support. So what it will be able to do is, if you have multiple of cores sitting there, which is a common use case with our customers, this tool can work on top of them and provide to all those and equally divide in the most appropriate and in the most optimized way onto the several DSPs which are sitting underneath. So overall, with many other features here, this Tensilica Neural Network Compiler is something which is an offline tool which gives you the most optimum performance for networks which are pre-known, which you want to deploy in the most optimum form on your system and get the most performance out of the DSP or the processor you have underneath. It helps you with that and get you the best performance possible. So with that, I will end the session on the Tensilica Neural Network Compiler. Keep watching, stay tuned for the next sessions.